Hi, it's Dr. Z. In this video, I will introduce the concept of effect size. By the end of this video, you'll be able to describe the importance of effect size in hypothesis testing and be able to calculate effect size for a z-test. Please feel free to pause the video at any time to take notes. What is effect size? Well, when developing a new drug, a researcher wants to know whether the drug worked or not. At the same time, the researcher wants to know how well the drug worked. Effect size is like a ruler that measures how well the drug or the treatment worked. In this video, I will explain how researchers use effect size to go beyond deciding whether the study worked or not. Step 4 of hypothesis testing is making a decision. It is in this step where you decide to either reject the null hypothesis, which means the treatment probably worked, or you decide to fail to reject the null hypothesis, which means the treatment probably did not work. Well, researchers need to go beyond the decision. By making a decision in step 4, significance only tells us whether the treatment worked or not. If the treatment worked, the decision does not tell us how well it worked, or in this case, how big the treatment effect is if there is one. Let's use this photo of Lego bricks in different sizes to explain. Imagine that we have found that a new cancer drug works, which means we rejected the null hypothesis. Now imagine that each Lego brick is the size of the treatment effect for this cancer drug. In other words, the size of the Lego brick is how well the drug worked. So, which size Lego brick do you want for your treatment effect if it was your mom, your dad, or your nana taking this drug? The largest Lego brick possible, right? This, my friends, is effect size and why it is so important. The concept of effect size was developed by the American psychologist and statistician Jacob Cohen. One of his most famous quotes was, "The primary product of a research inquiry is one or more measures of effect size, not p-values." In other words, Dr. Cohen valued how well a study worked more so than whether it worked or not. Effect size is the standardized measure of difference between the sample mean of the study and the population mean. This photo is a visualization of effect size, where it shows that the researcher will take the sample mean in red and the population mean in blue, and then calculate the difference between the two to determine effect size. Now, my personal definition of effect size is simpler. Effect size measures the size of the treatment effect. After conducting a hypothesis test, researchers should not just stop at making a decision about whether the study worked or not. A good ethical researcher always calculates effect size, regardless of significance, because of potential type 1 and type 2 errors. Effect size helps with making sense of non-significant results as well. For example, let's say your study was not statistically significant, but you calculated a large effect size. The effect size tells you that there is a large treatment effect, despite the study not working allegedly. In this scenario, the researcher should definitely repeat the study with a larger sample size to see if the study does indeed have a statistically significant effect. Dr. Cohen developed effect size conventions that are standard rules about effect size. These rules help to interpret the numerical values of effect size. We will discuss these rules later in the video. Let's review the steps to calculate effect size. For a z-test, effect size is called Cohen's d after Dr. Cohen. Step 1 is to use this formula. This formula looks very, very similar to the z-test formula. To better interpret what the numerical value of effect size means, Dr. Cohen provided verbal descriptions of effect size. Step 2 is to use effect size conventions stated in this table to determine whether the effect size is small, medium, or large. When interpreting effect size, it's better to err on the side of caution. For example, if you calculated an effect size of 0.35, it falls right in between a small and a medium effect size. In this scenario, researchers would opt to say it was a small effect size versus saying it was a medium effect size. Now, one important point here. When calculating effect size, you may calculate a negative value. This happens when the sample mean is smaller than the population mean. This is normal. However, from a statistical and reporting perspective, you will always report effect size as a positive value. Now that we've reviewed the steps to calculate effect size, are you ready to practice your new knowledge? I have one practice example for you to review. We will use the same lecture example that we introduced when calculating a z-test. A researcher wants to know if being told positive personality qualities will have an effect on physical attractiveness. Since we do not know what effect positive personality qualities will have, we conducted a two-tailed test. In our study, we had a sample of n equals 65 participants, and they were told positive personality qualities while looking at photos of individuals. The sample was then asked to rate these same photos on physical attractiveness. The sample had a mean of 220 on physical attractiveness that corresponds to a z of +2. The general population has a mu of 200 and a sigma of 80 on physical attractiveness, which forms a normal distribution. So, what is the effect size for this study? I encourage you to pause the video here and calculate effect size on your own first. Then resume the video to show the answers. Step 1 is to use the effect size formula for Cohen's d. We use the values for sample mean, mu, and sigma that were provided in the lecture example. The effect size for the sample is d equals 0.25. The box indicates the final answer. Step 2 is to use the effect size conventions in the table to decide whether the effect size is small, medium, or large. According to the table, the effect size of 0.25 is closer to a small effect size. Now, the number value of effect size will be added to the summary statement, and the verbal description of effect size will be added to the interpretation statement. More specifically, though, first you will add the d value to the second sentence of the summary statement after the p-value, and you will add a completely new sentence to the interpretation statement to explain effect size, which will be at the end. So let's review how these updated summary and interpretation statements would look like when adding effect size. The summary statement will remain the same with two sentences. The first sentence will report the mean of the sample, and the second sentence will report the z-score, significance level used, the decision you made, and now we'll have effect size added at the end. The interpretation statement will now be a minimum of two sentences. The first sentence will explain what happened in the study, and the second sentence will be that new sentence that explains how the verbal description of the effect size supports the results of the study. The highlighted sections are how the summary and interpretation statements are updated with effect size. Now, let's review these updated summary interpretation statements again but if we fail to reject the null hypothesis. Now, if the sample mean was a mean of 215, then the study was not statistically significant. The highlighted sections are how the summaries and interpretation statements will be updated. In summary, effect size is like a ruler that measures how well a research study worked. A good ethical researcher always calculates effect size, regardless of significance. The concept of effect size allows researchers to go beyond the decision of whether a study worked or not, and is an important Lego building block in understanding statistics.